Right then. So now here we are going to discuss the connections of the components, right? As much as we have learned different types of components and we discussed them, right? So now let's talk about the connections on how these components can be connected together. Now, apparently components can be connected in two ways. We have the series way and then we have the parallel way, right? In which these components can be connected. Right, fine. Now, we have the space between these two guys over here. So this side, we are talking about the series connection. And on this side, we are talking about the parallel connection. And you will learn the importance of why some other circuits are connected in series and why some other circuits are connected in parallel. Say, for example, you want to do your electrical engineering when you get to the university. So you will learn to understand how are you supposed to connect your components together. Are you supposed to connect them in series or in parallel? You will learn that as time goes by. Now, having a look at this circuit, what do we see? We see the components. This is the series component. This is the series circuit. We see the switch. We see the battery or the cell. And then we see two light bulbs. And then we have the conductor, the wire, right? Which links all of these components together. But now the way these components are connected, only one path for the current to flow, which is through. Say, for example, here we have the positive terminal of a battery, and then there we have the negative terminal of the battery. And we said that the battery will always move from positive terminal to negative terminal. But now, why do we say this circuit it is in series? Is because the current only flows in one path. It only flows in one path. It doesn't branch. It doesn't do what? It flows only in one path. That's why we say this circuit, it is connected in series. And you will learn the differences between the series and the parallel connection, okay? So that's why we say this is series. Now let's have a look at the parallel circuit. Now remember, here we have the positive terminal, and then there we have the negative terminal. Now have a look at this circuit, right? A charge, a current will flow from here, from positive terminal. But now I want you to understand that because we have a battery this side, not a battery, a bulb. Because we have a light bulb this side, which is this. And we also have a light bulb this side, which is that. Look what's going to happen. A current, it is going to split, meaning current is going to be divided into two paths. Can you see that? So meaning we have path 1 at the top, we have path 2 at the bottom. So when current starts to flow from here, therefore, there will be a current that's going to move inside of this path, and there will be a current that's going to move inside of this path. So for a fact that our current, it is flowing in different paths. So that means these components, they are actually connected in parallel to one another. In this case, which components are connected in parallel? The light bulbs, they are in parallel. Let's have a look at here. Which components are connected in series? The light bulbs are connected in series because the current that's going to pass here is going to be the same as the current that's going to pass there. But here, the current that's going to pass here is not going to be the same as the current that's going to pass there, again, depending on the resistor, the magnitude of, but you learn that again. We can have total current be 3 amperes, and the other current passing here is going to be 1.5 amperes, and the other one is going to be 1.5 amperes. Or depending on the resistor, the other current could be 2 amperes, the other current could be 1 amperes. You will also learn to understand that, okay? So these are two types of different connections of the circuits. I hope that was clear. Know your series and your parallel. And the difference between the two, current is the same throughout. Here, current it is not the same throughout because it's going to have to branch. It's going to have to split into two paths. That's a parallel connection. Now, what we see over here, we have a circuit represented by this picture. Use the symbols of components to draw representing diagrams, which is the description. So you can open up your mic because I want to ask you a simple question so that we move on. What connection is presented on this circuit diagram over here?
Parallel.
It's a parallel connection. How did you see that this is a parallel connection? What made you what made you to decide that this is a parallel connection? I'm listening. What makes you say that this is a parallel connection? You said this is a parallel connection, right? But what's the reason behind that?
Is it because the two light bulbs are
Come
on
again?
top of one another?
It's because the two light bulbs are what?
One light bulb is above the other bulb, or because of the connection of wires.
It's because, yes, I love that. Not the light bulb is because it's on top of another. Some circuits, we can have light bulb on top of the another light bulb, but that does not say they are in parallel. You look at the connection of the conductors. So you
Wires.
are exactly conductors or wires. Okay. So we can see that this, if this is a battery, okay, we open the switch. I mean, we close the switch, and therefore you see, look what is happening. Current will flow from here. Let's say this is a positive terminal. Current will flow here, and the other current will flow there. You see, the current will branch. And therefore, when the current branches, so that means we're going to have two different paths. We're going to have path to this one, we're going to have path to that one. Therefore, this path will take its current and that path, and then they will combine, and then the total current will move again to the negative terminal of the battery once more again. Okay? All right. So now, here, they want us to use the symbols of components, right? We've learned the components. These are real kind of pictures of the components. So they want us to use the symbols. So how are we going to use the symbols? Doesn't matter how you draw your circuit. What matters is we need the components together. So this is how I'm going to draw this circuit, okay? I'll start with the switch. You can draw it however you want, okay? Feel free to draw it however you want. It's still fine. I have the switch over here. And then the switch, it is actually open, it is actually closed, right? The switch, it is actually closed, right? And then I have my battery over here. Let me say negative terminal and take this to be positive terminal. And therefore here, and then here, and then we have there. Here we have a light bulb. And then there we're also gonna have a light bulb. We have this path, which is this one over here. And then it joins with this one over there. And then we have a closed circuit like this. Remember, there's a light bulb. There's a light bulb. Then this will be my positive terminal, and that will be my negative terminal. And therefore, now these light bulbs, they are connected in parallel because current, when it gets here, the other one will come this side, and the other one will come that side. That means the current will split. Therefore, we have the symbols components. These are the symbols components. We show our battery, we show our switch, we show our light bulbs, and then we have that. Okay. All right. So also, if you have time, draw the electrical circuits. You can draw these circuits using your light bulbs, okay? Also draw this using your light bulbs. I mean your symbols, not your light bulbs, your symbols. Right. I hope that was clear, okay? We spoke about the electricity, we spoke about the components, we spoke about the connection of the components. Now I want us to talk about the potential difference. Remember what they say to you. I say we call it the potential difference or we call it the voltage. Ne? Or we can call it the EMF. Now, when you talk about the potential difference, look, let me show you something, okay, so that you can understand. Let's say here I have a battery. Okay, let me say this is a battery, actually. This is the battery. Ne? So now, I say to you, it's a battery, and therefore I'll take this to be a positive terminal, and then I'll take that to be a negative terminal. And then let's say maybe we have a wire connected to our battery until it gets there. Now here's the thing. Here's the deal. Here's the story. Now, a battery, what it does is, in fact, let me do it like this. I'm changing my mind. Let me do it like this. So let's say we have a battery. Let me draw it. We have a battery. And then we have a current. Ne? Not the current, the wire. I want to draw my wire in this way so that I can explain something. This is the wire. Okay, oh my God, my drawing is very, very horrible. So that's a wire. Ne? That will be a wire. And let's say, remember what I said to you from the beginning. Ne? I said to you, a wire, it has the electrons inside of it. Because why? It is a metal, right? It's a metal. So since well, a wire, it is a metal, so that means we have free moving electrons. And these free moving electrons, we call them the delocalized electrons because they simply vibrate. But when you connect a battery onto this wire, what's going to happen is a battery will give a potential difference or will give a voltage to this wire. Now, if there was no battery at all, there was going to be electrons, but these electrons, they were just only going to vibrate. They were just only going to move, not flow. They were just going to move. But because now we have a battery, we have the positive terminal this side, say we have the negative terminal this side. What's going to happen is a potential difference. It is potential energy of a battery. A battery will potentially give energy to these neighboring electrons that we see over here. So when a battery gives an energy to these electrons, the neighboring electrons will transfer that energy to the other electrons. And then these electrons over here will transfer the same energy to the neighboring electrons. These electrons over here will transfer the energy to the neighboring electrons. You see, these electrons over here will transfer the energy, will transfer the energy, will transfer the energy, will transfer energy. And therefore, the electrons, when they transfer that energy, they will start to move or they will start to flow inside of the circuit. So what made these electrons to flow inside of the circuit? It is the potential difference from a battery. So guys, listen, when these electrons or when these charges, we call them the charges because electrons, they are negative in charge. And so why we say they are charges. So these electrons, when they flow, now we have what we call the current. Ne? We have what we call the current. The rate at which these electrons flow or the rate at which these charges flow, we call that a current. So that means current depends on the voltage from a battery. Because how would these electrons flow if there was no battery? We need a battery so that there can be a flow of electrons inside of the resistor or inside of the conductor. You understand what I'm saying? So that means the current depends on the voltage. Because without the voltage from a battery, there is no current in the circuit at all. So what we see over here is the flow of the electrons, okay? Flowing electrons, they show you in the conductor. Just that I draw my conductor like this. This also will represent a conductor again. So that means we have the electron, and they are flowing inside of a conductor. What made these electrons to flow inside of the conductor? It is the voltage. Or it is we can call it potential difference, or you can call it the EMF. So where does the EMF, the voltage or the potential difference come from? It comes from a battery. It's an energy from the battery that will make these electrons to flow through the circuit. Is that clear, guys? I believe it's clear, right? So again, here we're still emphasizing, I have already explained everything under the potential difference, that the potential difference means that there is a difference in potential energy between 2 points. Now, when you talk about the different energy between the 2 points, let's take these 2 points. I want this diagram of mine. Um, let's take this point. We have this point, and then we have that point. So from this point, which is point A, I'll call this point B, the potential difference at this point, it's high because it's a positive terminal. And then the potential difference at this point is B is zero because it's far from that. But because the electrons are flowing, the potential difference can be different at different points, okay? So that means here when they say to us, difference in potential energy between 2 points. So charges move from where it has high potential energy to where it has low potential energy. Where is high potential energy? This side, it is high potential energy. But because Mona, we have low potential energy, meaning these charges will move from there to there. Then and so forth and so forth and so forth and so forth until they get to a low potential difference. Therefore, the potential difference will be the same throughout the entire circuit. So point A has a high potential difference because it's where the energy will start to flow, right? And therefore, this side we have the low potential difference because it's far from the positive terminal. We are waiting for electrons to come this side. When the electrons come this side, therefore the potential difference has moved to this side of the battery as well. Okay. So don't forget that, let's have a look at these pictures over here, okay? So here we have high potential difference, and this thing is gonna swing down there where there is a low potential difference, okay? So that's what it means by a high and low potential difference. And then again, here's the thing. I say to you, a battery, it gives potential difference. And then having a look at these two batteries over here, they are different, okay? Because this one, it says it gives 5 volts. This is a 5-volt battery, and this is 1-volt battery. Like I said, the battery that you see at home, the one that you use for the remote controls, the other, it's 1.5 volts, okay? So this is 1 volt. Let's say, for example, this one is 5 volt. So depending on the potential difference depends on the size of the battery, right? So here, because we have 1 volt, so how will be the flow of electrons inside of the circuit compared to this side of the circuit? Which one it is going to flow faster? The one that has high voltage will flow faster, meaning here we're gonna have high rate of flow of charges, meaning we're gonna have high current, okay? We're gonna have high current. So if we have high current, it's because we have what? We have a high potential difference. So here we have, compared to this one, we have low potential difference. So that means we're gonna have lower current compared to this one. Okay, so that's what we mean by potential difference. We are referring to a battery. So now, like I said, the potential difference is all about the energy, right? We're still under the potential difference. So this difference is potential energy between the 2 points is used to do work. The work can be in the form of light, heat, or other types of energies. This is what is happening. We have a battery, right? And I say to you, a battery has a potential difference. So what battery do is, this man over here will represent the potential difference. So remember, we have the connecting wire over here, or the conductor. So when the battery pushes those electrons on a connecting wire, I told you how it is going to move. I have already made an example, explanation on this diagram over here, that this battery will push these electrons, and therefore these electrons will push the neighboring electrons, will push the neighboring electrons, push. They flow, and there is a flow of current in this circuit. So what they did over here is exactly the same thing as what I have already discussed there with you over there. But here, they're just only referring to the energy, that the potential difference is the potential energy of the battery that is going to push. Remember, for us to push the electrons, we need energy. Okay? We need the energy. Now, here we have a quite very important statement, which says that if the resistance between the 2 points increases, the potential difference will also increase. Let me show you what do they mean. I'm going to draw two different circuits, okay? Say we have a battery over here or a cell. Then we have a closed circuit just like this. Again, let's say we have a battery over here or a cell. And then we have a closed circuit just like this. But this one, let's say maybe it has a resistor. And therefore we close the circuit. Now, the difference between the two circuits is that this circuit, it doesn't have resistance. It does have, but you neglect it for now. It doesn't have, we'll take as if it doesn't have resistance at all. This one, it has resistance by this resistor. Resistor brings resistance. So remember, a current will always move from positive terminal to negative terminal, positive terminal to negative terminal. So when current starts to move in this circuit, when the current starts to move in this circuit, now we have the resistor, and then you know what does the resistor do? It disturbs the flow of charges. More, we have a smoother flow of charges because there is no resistor or resistance. So here, because we have a resistor which brings resistance, mean this, it disturbs us. It is disturbing the flow of charges. So now this is what is happening. Ne? So if the resistance between the 2 points increases, now let's talk about the resistance this side. Here we have low resistance. Now I'll just say low R. We have low resistance compared to this one. And then here in this circuit over here, we have high resistance. Ne? We have high resistance compared to this one at the top. Right? So here, because we have high resistance, that means the resistance between the 2 points of the battery, these 2 points of the battery, it has increased. So that means because here we have high resistance, what does that mean? That means we're going to have the high potential energy. So that means we need a high battery over here because we have resistance. So meaning if we have one cell here and then here we have one cell, but here we have resistance. So to accommodate this circuit over here, we have to increase by another cell so that we can have high resistance that is going to be distributed throughout the entire circuit. So always know that if resistance increases, the potential difference also increases. Okay. Feel free to ask if you really do not understand. Now, we are still under the potential difference, right? You see, there is a lot to talk about when it comes to potential difference. So now, this is the definition, or this is how we define the potential difference. We say, they will ask you in exam, make sure that you know how to define this. What is potential difference, or what is voltage? We say the voltage or the potential difference is the difference in the electric potential energy per unit charge between any 2 points in a circuit. So when you calculate the formula for potential difference or voltage, we're going to say V is equals to Q. I'm lying. It's going to be, looking at the definition, it's going to be V is equals to energy, let me say E, energy over charge. It's energy over charge, ne? Energy over charge. We have charge over there. Ne? That's how we define. If you forgot how to define, think of this formula. Ne? This formula, it actually describes this, what we see over here. What is potential difference or voltage, which is V? We say it is the difference in electric potential energy. E is the electric potential energy. Per means this thing. Per is like E per Q. Ne? E divide or per unit charge. Remember, Q, it is the charge, represent charge per unit charge between 2 points in a circuit. That's how we define potential difference. And this is how we define potential difference using mathematical concept or using the equation. It is still the same thing, but here it is in words, and in here it is in a form of equation or in mathematical way. So remember, I said to you, potential difference can also be called the voltage. What is this thing here? It's not the voltage, it's voltmeter. What does the voltmeter do? It's a component that measures the voltage. Remember, we started with that. Don't confuse. I get it, it's V here. But this V, because it's drawn on the circuit, that means it's a voltmeter. It's a device that measures voltage. So electrical potential difference, which is this, what is this? Electrical potential difference, which is this, which is V across the poles of a battery, when no current is flowing, is known as EMF. When a current is flowing, is called the potential difference or voltage. Now, here's the thing. Now you're gonna understand the difference between EMF and potential difference, but they're the same thing, but be careful. When you talk about the EMF, let's say we have a switch over here, right? We have a switch over here. And then when this switch, it is open, when this switch, it is open, we're not gonna have the flow of electric current inside of this circuit. Why? Because the switch, it is open. But we have the voltmeter over there. And this voltmeter, it is connected across a battery or a cell. That's where this voltmeter, it is connected. It is above the battery. So this voltmeter will read the voltage of the battery only. So the voltage of a battery, it is called the EMF, because there is no current at all that is flowing inside of the circuit, but that does not mean the voltmeter won't work. The voltmeter will still work, even though there is no current. Voltmeter doesn't work with current, guys. Voltmeter doesn't work with electricity. It measures. It doesn't work with, whether there is electricity or not, voltmeter will always be able to work. So this voltmeter is connected across this battery, but we have the open circuit. Therefore, the reading that we're going to see over here, it's going to be called the EMF. But when we close the circuit, like that, now the circuit, it is closed. When you close the circuit like this, now there will be flow of electric current in the circuit. So this voltmeter will now read what? Will no longer read EMF, will now read the potential difference or the voltage. So this EMF will drop a little bit. You'll learn that when you get in grade 12 why it drops. You don't need to know that. It will drop a little bit. So when that drops, therefore, this voltmeter will read the potential difference. Now let's talk about this. This is also important. A battery, it is made up of chemicals inside of it. So what's happening with the battery is that, maybe you didn't know that, but by now you know. That's why I used to tell these kids years back, don't eat or don't try to chew or to bite on the battery. There are chemicals inside of the battery. So those chemicals, they can be harmful in your body. So you don't have to, you don't bite on those batteries. They used to bite them so that the batteries can work, and they would work. So the chemicals inside of this battery, what they do is they react. I agree, those are the chemicals. So they react with one another. And when they react with one another, we say the chemical energy will be converted into the electrical energy, because it's a battery and it gives electricity. So these chemicals inside of the battery, they will react with one another, and therefore this chemical energy will be converted into the electrical energy. And therefore, when this chemical energy converted into electrical energy, this will allow the charges to flow in a circuit. So listen, guys, sometimes the battery gets hot. You know why the battery gets hot? It's because, I don't know, you will learn again this again in grade 12, né? The battery gets hot sometimes because inside of it there is a resistor. Inside of it there is a resistance. Inside of the battery itself, it has resistance. Okay, so the battery also offers some resistance to the flow of what? To the flow of charge, and so it converts some potential energy to heat energy inside of the battery. So meaning the potential energy that is inside of the battery, because of the resistance of the battery will convert some of that potential energy into heat energy. And then when you touch your battery, it feels hot. More especially when you're using your phones. I know right now you're using your phones. Sometimes your phones, they overheat. But remember, a phone has a battery inside of it, right? And those chemical reactions that are taking place inside of the battery, they're continuously reacting to supply your phone with power. right? And you have to understand that that battery of your phone, it has resistance inside of it. So some of the potential energy inside of the battery of your phone will be converted into heat energy. That's why you will feel that your phone, it is overheating, it's feeling hot. It's because of your battery. Okay, so that's what battery does actually. So the unit for EMF and voltage, we use V, which are called the volts. So here's the difference between the EMF and the potential difference. So the EMF is when we have no current in the bed in the circuit, and then terminal potential difference is when we have the current flowing in the circuit. We have already spoke about this. And then EMF and potential difference are both measured in volts, which is letter V. We use the volts. So we have voltmeter, which measures voltage. Voltage, it is measured in units that are called the volts, and then the units are represented by letter V. Don't confuse these things, okay? Make sure that you understand. And then we have the formula sheet, and then we have the potential difference calculations. So here I'm just talking only about the potential difference, as you can see. So V is for voltage, W is for work, or now I was using E, and then Q is for charge. So having a look at this for triangle, you see we have V is equals to W over Q. We have V is equals to W over Q. W, or now I said E for energy, does not matter, okay? So we can use W or E. So, but W, it means work or it means energy. And then the units for energy, we use joules. We call them the joules. Okay, joules. And therefore here we have voltage, which are units. The units are called the volts. Volts. And then here we have the charge. The units are called the coulombs. Yeah? We call them the coulombs. We call them the coulombs. Yeah? It's coulombs. So these are the units that we use for charge, for work or energy, it's joules, for voltage, which is letter V, it's volts. And then the formula that we use to calculate the voltage is this one over here. V is equals to W over Q. Now let's have a look at example number 1. Example number 1, based on the calculations, if we have 120 joules of work is done in lighting a bulb when a charge of 20 coulombs flows through it, what will the potential difference be across the bulb? So what are we looking for? We are looking for potential difference. So data given is, we are actually given, let's see, we are given the work, which is 120 joules, right? We are given the charge, which is Q, which is how much? Which is 20 coulombs. And then what are we asked to do? We are asked to determine the potential difference across the bulb, which is V. This is what we are looking for. So which formula are we going to use to calculate V? From our formula sheet, we have learned this, that V, which is potential difference of voltage, is equals to energy or work over charge. Now, what is our work or energy? It will be 120 joules divided by our Q. In this case, it will be how much? It will be 20 coulombs. Therefore, what will be our V or our potential difference? You're going to say 120 divided by 20, we get 6. So be careful, you don't just write 6, you write 6 volts. So that means our voltage will be equals to 6 volts. You just write V, don't have to say volts, it's V, the units. And therefore we add that. For your homework, I'm going to give you example number 2. And therefore, with this time that is remaining, okay, we'll use another time when we meet again to continue, okay? But for your homework, I'll give you this example number 2 to do today.